All right, new day and another laptop that needs to be saved, and this time we have an Alienware M18R1. Now, this one was purchased on eBay. Looked like something kind of simple to fix. The laptop is like in really good condition. The customer said that the DC jack was broken into pieces. He tried replacing the DC jack. It did not solve the issue, so I suspect there's something catastrophic on the motherboard, but I haven't taken a look at this yet. Let's take a look together and see if we can get this figured out. All right, first thing I want to do is see if it turns on, which it probably won't because that's what they said, but that's the routine. Press the power button. Let's go ahead and open the bottom up and take a look inside. So I've seen this tons of times, so that DC jack just completely shattered. Now what we have here on a DC jack, and let me go ahead and just kind of, while I'm unscrewing this, I'll explain. So these laptops run on a 3-wire system. It's usually a 1-wire circuit, but I like to call it a 3-wire system. So you have a positive, you have a negative, so that's gonna carry your actual main voltage, 20 volts. And then you're gonna have a PSID line, which is a communication line where the laptop and the charger talk and say what size charger it is, right? So if the 20 volt line gets shorted out to that middle line, which is only 3.3, then we have some problems. So we probably have something blown on the board because of that. A lot of times it blows out a diode or resistor or something. All right, so the bottom is off. All right, take a quick look around. So we do have the battery unplugged. You got to flick the battery cable. That's how you know it's unplugged. The main battery is an OEM. We have the serial number here. I do see that we have one NVMe populated. This one actually takes 4, some 2230s, so 2280s. How much RAM do we have? We have DDR5 and it's 16 gigs, so 32 gigs. Which isn't too shabby. This one has 3 fans, 2 on the CPU side, 1 on the GPU side, and this is gonna be the fan that cools the RAM. This is the machine that I do a modification on the fan where I cut out this section here where it blows because there is a short usually on this power rail. Now, we don't know what we're messing with yet, but I'm gonna plug in my own DC jack because we don't need this junky one on here. It looks like the connector is kind of busted here. So if we look here, this is where it plugs in. And the top of this thing is just kind of broken off. I don't really care. We're gonna set this off to the side. Maybe we'll melt it back on there. Maybe we'll just throw it away. Let me get my bag of jacks out. So this is the correct one right here. All right, so we have that plugged in. Let me reset our spike power meter. So if you're new to the place here, that's the spike power meter. We have a max current and we have a little current chart meter that we can pull up there. So I'm in continuity mode. We're just gonna do a couple pokes. There's not very many pokes we can do on this side because I don't know if you noticed, but right after the DC jack, there's nothing over here. All this stuff's on the other side of the board. And then I don't know if you noticed, how many coils do you see on this side of the board? How many inductors do you see on this side of the board? There's only one here, which is for the DDR5 RAM. That's it. All the rest are on the other side of the board. So there's really not much you can measure around here. We're gonna measure the DC jack. And the DC jack is measuring, that's ground, and that's not shorted, so that's measuring fine. It is time to plug it in. We want to plug it in thermal, keep an eye on the power meter there, and we just want to see what it does. So it just does 0.01, 0.02, perfect. That's what we want, except there's something that you're missing here. This machine should power on its own. So it theoretically should actually jump up to 0.6, 0.7, and then kind of sit there at 2 amps to 3 amps for a little while it's doing a startup process. I don't see anything getting hot. This kind of looks like just resting current that you would think that that's fine, but it's not. Let's see if we can hit the power button. It probably won't do anything with the power button because 0.02 is not enough for this machine. So let me press the power button. Oh, what was that? Did you see it right there? I pressed the power button for a second. It did something. And now it's resting at a little bit higher current. So I plugged it back in. That was inrush current when I plugged it in. I'm gonna press the power button again. I just want to see what it does. Okay, so right now it's sitting at 0.01, 0.02, right? So 10 to 20, so maybe 15 milliamps. Press the power button, 1, 2, 3, and it does a little spike up. And then now it's just sitting there at 0.02, 0.03, so 25 milliamps or something like that, right? So let's see if there's anything getting hot now that we have a little bit more current coming through here. I don't see anything. So what do we have to do next? We have to pull the motherboard out. I mean, one thing we could do, actually, let's think about it. Hold on, I got an idea. So I want you to think about it like this. This DC jack, right? It feeds some MOSFETs on the other side of the board, and those things are made to protect the board. It also goes to a circuit where it has the PSID circuit, which is the communication line between the charger and the laptop, right? But what's the chip that's responsible for turning on and off the MOSFETs where the DC jack goes to? The power management chip. So if the power management chip is blowed up, which I would think it probably is, because we had all this mangleness going on, then it will do this exact thing. Or if it detects a short on the board, it will do this exact thing. Let's plug a charged battery into it and see if it powers on. I've seen it with a blown power management chip, but the battery will power it on. So at least let me do that. But you know what I want to do? I'm going to take out this SSD and I'm going to take out the Wi-Fi card. So let's just try a different battery first. That way we can kind of figure out, is the board working, or is it dead because it's detecting a short on the board, or is it dead because the power management chip is blown up? This battery is inferior to this M18, but it actually goes to the board because this motherboard actually goes to an M16 and an M18, and this is the 16-inch version of this, so it will work. What voltage do we have on this battery? We got not enough. All right, so there's no point in pressing the power button. So I plug in the battery, and we have 0 volts on the battery. What does that mean? Does it mean the battery's dead? That were right. The first chance is the battery's dead. Second chance is there's a short on the board, and it's telling the battery to shut itself off. Let me grab one more battery, just to confirm our suspicions. Okay, measure the battery first. You can't measure it without it being plugged in the board because it's turned off. That's the only problem. So I can't measure it outside of plugging it in. And we got our 11.3 volts, so the first battery was dead. So this board has power now. Will it turn on? All right, so I'm gonna press the power button. All right, nothing's happening. All right, well, I guess this laptop's dead. All right, let me go ahead and get the motherboard pulled out. So at this point, still doing nothing, and the battery is charged. We know that we had power in the system. We know that we put voltage in the system. All right, and the motherboard is out. I'm just kind of like looking around for a second. Does anyone see something suspicious? Like, I don't even understand it. Let me know if you see it. On the top, it's right here. It's in the view. You got it. Look at this. So I think our problem is here. There's actually a gouge across that. It's not too big. Well, I'm gonna take the heatsink off. Let's just see what disaster we have underneath here. Yeah, and we still have our liquid metal on here. So let's look at the liquid metal. Looks okay. It's within the barrier. See how this one has a really nice thick barrier? We need to still look for some liquid metal, some LLM. We also need to look for blown components. So physical inspection is needed for sure. This is gonna be one of the lower end. This may be a 30 or 4080. Might be a 4080. We're missing a couple of RAM, because I think the 4070 has a lot smaller die than that. Over here's where our input MOSFETs are. Got a set of 4 of those guys. Current sensor resistor, charging coil, another set of MOSFETs. There's our power management chip. So our power management chip is not blowed. It looks good. Could our issue only be someone messing with the BIOS? There's the BIOS again. I mean, what is this? What do we think here? Do we need to program it? Something seems askew with that BIOS. Is that a hole? That's a hole. No, it's not. It's glue. Never mind. This is hot glue. This is hot glue. This is hot glue. This is hot glue. Oh my God, this is hot glue. They hot glued the BIOS chip on. Now it's coming together. So if you hot glue something, this is never hot glue anything into a gaming laptop because these machines run so hot. The hot glue will melt, people. It's in its name. It's in its name. That would make sense that maybe they got it lined up, maybe the machine even turned on, but then it just started surfing because it got so hot. Check your donor board to see if this is the correct BIOS chip. It should be a 25Q256JV. I don't know, that's my guess. Let's see what we got here. So here's a board. This one's a 25Q256JV. And this is a 25Q256JV. How are we gonna get this thing off without making a mess? I mean, how did they get it off? That's kind of my next question is like, if they were able to get it off, but they couldn't put it back on, how did they get it off? All right, here we go. Yeah, so I gotta think about it. So if I put like a tissue paper down on it or something, right? Then I can melt it and have it stick to that, right? Isopropyl will kind of make it come unstuck, right? Because this isopropyl's on here. I'm just gonna try to have it come undone here. I just want to put a new BIOS chip on there. Are y'all okay with that? Or should we try to salvage the old one? IPA worked just fine. So now y'all know. So new BIOS chip, concurrence there. IPA worked really well. It sure did. So that's ready. Let's just grab a new BIOS from something. 256JV, a Q. Cool, I'll just steal this one off this board. So this one already has stolen parts, so that means I could steal it off of here. Look at the CPU on that. There's a crack right down the middle of the CPU. All right, so that's the chip we're gonna take. Here's our brand new BIOS chip. Now this BIOS chip already has a programming on it, but you know what? That's not good enough for us, because I'm gonna put a nice, clean BIOS on there that has no service tag or anything like that, so we can program it. So I need to put it in this little reader to program it. All right, so this is our old one. And then we have this one in the programmer. So I want to see if it's detected. And 256Q, JV, it's a Winson. So I'm just gonna load a BIOS on here that's fresh. And so clean, clean, clean ME. Good. That'll work. There we go. It's going. All right, it's programmed. So this is a fresh BIOS that I'd already programmed, pre-programmed. All right, so you can see this. We have pin 1 here. That's this little triangle. It's pointing to pin 1. There's pin 1 right there. We just set it down like that. So I'm gonna wait for these to get nice and shiny. There you go. You see how it shined up? And now we'll come in with the chip, put it back down. This is a totally different chip from the original one. And then once we get it lined up, there we go. Nice. Okay. So we'll do this under the thermal camera. What we should see happen is the CPU coming on, and then all these power stages and all this power rails and all this stuff come up. You ready? 3, 2, 1. 0.01, 0.02, that's all it takes. So the BIOS had nothing to do with it. It's doing exactly the same thing. Okay, so this still isn't working. Now we have to start tracing down power rails and where the power is going. We need to figure out what's up and running. So the BIOS was not the issue. I put a brand new BIOS on here so we can wipe that out of there. What I want to do next is I need to start measuring where the voltage is going, right? So our DC jack comes to these MOSFETs first. So let's figure if it comes over here. We need to see if our 3 volt and 5 volts are coming up, see if we have shorts on the board, see if we have any other broken chips. We didn't see anything like that, any burnt chips or broken chips, but let's plug it back in. We'll just take some measurements and figure out if we have any weird stuff going on. So DC jack is plugged in, and so let's measure. I believe it comes through. Where's it come through at? I thought they came in right here. Well, let's measure over here anyway. So we get 19.8 going through there, 19.8 coming out, 19.3. I don't like that. Why do we have a voltage drop? This should be 19.8 all the way across. So we have a voltage drop across these, so we could have a bad MOSFET, but let's just keep going. 19.3. And then this is probably the battery charge current area. So let's go ahead and measure our power management chip here. All right, this is very tiny, so I need to make sure not to slip. So this should be 20 volts on this pin, 19.5. Again, I don't like that voltage drop because we should actually have 19.8 on that pin. And then the second pin should be 5 volts, and we got 1.9. So there's our issue right there. So we should have 5 volts coming out here to power up all the other chips. And so that's messed up. And then this was 9552. So I think it's this pin should be our AC detect. So our AC detect's not detecting an AC adapter. Okay, so here's the area you need to check. We need to actually measure to see if we have a short on our PSID pin because we knew that we did have a blown up PSID. Let's flip this over, and I don't want to get liquid metal all over my desk. Let me take this liquid metal off of here. Maybe I should just put tape over it. Yes, that's a good idea. That's what I'm gonna do. All right, let me flip it over. What I wanted to check was the PSID pin, and I want to see if we have a short or something weird on that, and to see if we have our 3.3 volts on there too. It actually should be 0.8 on this one whenever it negotiates, but it should start at 3.3. So first we'll just do continuity mode, and it's always gonna be on the ground side. I wanna see it be 3.3 for a second, and then drop down to 0.8. Well, it's 2.9. All right, let me go thermal. So a lot of this stuff is reflections, that's why I'm moving it around a lot. Now we can see, what's this? Okay, that's gonna be the 3 volt and 5 volt power rail. So are those things on? All right, so they're not on, but it's warm. So right here, you see it warm, but they're not on. You see that? That's a sign, that's a sign. What else do we have that's warm? So that was the 3 and 5. This is the EC chip, it's not on. It should be on, but it's not. What else do you see? What's this over here? Is that just a reflection? It's a reflection. All right, so thing that I see that looks suspicious, I mean, we have this, what's that? That's a diode or something? No, I don't, that's some sort of MOSFET or something. That's this thing right here. How do you say that? Richex? I just say him Rex, I call him Rex. Now you're telling me, Lead Farmer, so a 5x equals is just a 5x equals, right? So I could actually just replace it with any 5x equals, and so then what's the 9G? Does the C23 mean anything? Okay. And so that would mean that it's a 3 volt and 5 volt regular and it's done, right? So I can grab any 5x equals off of any board and it should just plug it in and work. Are all the same. Okay, Lead. So let's see if we can find a 5x equals. 5x equals is what we need. We haven't even measured for shorts actually. Let me measure for shorts around here. Chipset, 20 ohms. So we got 80 ohms, 90 ohms. That seems pretty low. 100 ohms, that's bad. On the 3 volt or 5 volt, I don't know which one it is. Take it off the daughter board. Yeah, we could have a short on the daughter board. Good point. I'm gonna just make sure this is still the same. 175, so it's still going up. So there must be something weird on that one. Like I have a couple M18s here. Let's just steal the chip off of it. So first we're gonna pull the customers off. Now we're only guessing it's this chip because this chip's getting hot. We're missing our full voltage here. Now we could have actually just changed out the power management chip first, but because this chip, the VDD, the 5 volts is supposed to come out, is actually a lower voltage, and this chip's getting hot over here, but it's not producing anything. It was making me think that that's bad. Always start upstream. So upstream would be change this one first, right? So intercell is getting the 19 volts, but it's not getting the 5 volts. The 5 volts is 1.9 volts. It looks like upstream is kind of going to be the way to go. And we spent a lot of time doing a little side tour. Let's just change this out. This is, you know, also with the broken DC jack, this could have been the issue the whole time, but I've done this before where I've like changed it out and it ends up being downstream from it because it's, you know, having issues with powering whatever chip's plugged into, and the fact that it is warm over there is making me think that. But, you know, again, it's like sometimes you take the clues from other repairs and then you mix them with this repair and then that becomes the wrong answer. No. All right, so we'll grab that one off of there. So that was the bad one. We're gonna make a bad pile here, bad quote unquote, and here's our good one. Now this board that I'm taking it off of works. It actually powers on, it just gives a 2.7 error. It will work on external monitor though. So this thing works on external monitor, you can just never get a screen display. I think I know how to fix that now, so that's why I don't want to really destroy this board. But at the time, I couldn't figure out what was wrong with this one. But I have had something similar since and I've figured it out. There we go. Now we have a new power management chip, never been used before. Let's see what it does now. All right, so we're gonna plug it in. If we see the CPU light up, then we're good to go. 3, 2, 1, powered in, plugged in, still doing exactly the same thing, okay? And we still have, wait, oh, that's the EC chip is on. That's the EC chip right there. That was not on earlier. So there's our 19.9, and then this second one should be 5 volts. What? We have 5 volts now? So it was that, but it's a combination of things, I tell you, because it's still not on. So what about our AC detect is working too. So now let's see if we have our 3 and our 5 volt power rails. Who knows? This might be one of those things where it's like a catastrophic chain reaction. 3.3 and 5 volt are working. Well, I'm glad we did not change that out first. Does it charge the battery? Let's see if it charges the battery. That would actually be a good check. All right, I have a battery plugged in. Let's just see if it charges the battery. So it should start right there and then jump up to like 0.23 and then go to an amp or so. Give it a second. We might be missing 1.8 still, actually. Let's see, we have 0.8, so the chipset's on now. We got 1.8, we got 1.8, we got 3.3, we got 5 volts. It's not charging the battery. We've already replaced the BIOS chip. So now it's the EC chip for sure. All right, so EC chip, embedded controller, right? So it's just a microcontroller running a loop of code, like 160 kilobytes or less or more. I don't know what size this one is. But it's really just checking GPIOs, inputs, outputs, it's communicating with a bunch of different chips, but it's actually responsible for starting the board, turning on the power supplies, turning on, making sure things are okay. And if it's having a bad piece of programming on there, or someone has messed with it, then it won't work and the board won't start. And since we had the BIOS chip hot glued onto the board, and we have this suspicious discoloration around this chip here, or that almost looks like flux, or it could be hot glue for all I know. Let's pull this chip off, let's take a look underneath. This is a BGA package, so it's gonna have a bunch of balls under there. It's not the worst chip to reball. It's not the best chip to reball. Okay, let's pull this thing off. Where's that? So I barely heated this and there's stuff coming out. So there's definitely some sort of flux or something underneath there. You see how I'm barely doing anything? There should be nothing coming out underneath that, okay? So I'm just gonna reflow this first. So right as it starts to move, then we can tap it. Tap, 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 tap. Okay, looks good. Do we think the EC chip just reflowing is gonna fix it, or do we need a new EC chip, or do you think we need new EC chip programming? We're gonna pull it off afterwards. Right now it's just the fun of science, right? Just reflowing it, see what it does. Plug it in, and we're just sitting there at 20 milliamps, 30 milliamps, whatever it takes, and that's not enough. That ain't enough. So let's go ahead and pull it off. All right, so let's pull this EC chip off, and I guess we'll start with reball, I guess. All right, so we're gonna pull this one off. I don't know if it's worth just reballing this one, putting it back on, or if we just take our donor and put it on there. Okay, so I'm gonna pull this off. Clean pull. Why do we have a big ball right there though? That's a huge ball, but everywhere else is even, and they almost look like they're undersized. They almost look like someone had pulled this off and put it back on, and then didn't do it right. So I don't know. That's weird. Do you see that huge? I mean, it's only on that one pin. Like all the rest of them are fine. So all the rest are equal, and then even, they're all equal on here. I kind of want to reball this one because it doesn't look like there's enough solder on these. It looks like somebody had already pulled it off, put it back on. And I'm kind of interested to know if the chip actually works. Well, we're going in for the reball. So that's ready to go. And now we just need to get this cleaned off and ready to go. If this is your first stream, I've streamed twice a week. So it's Wednesday at 6 p.m. Central and Sunday mornings at 9 a.m. Central. Let's see. So I have a lot of these multi-stencils. I don't have a stencil for this chip itself, but I usually just find one that fits. There we go. It's this one. There it is. We found it. All right, so it's this one right here. Let me clean this off. Now that we found it, I just got to get the stencil cleaned off. All right, let's get this lined up. So I'm going to put the chip on this. This is a magnetic base. This is a little rubber pad, and I'm just going to set the chip down right here and put just a little bit of flux on here. You don't want much. You just want something where it's not going to not stick. There we go. So we're going to take a little bit of my solder paste here, and it's been open for like a month or 2 or 3, so it's really nice and dried out. And you're just going to smash it in here. So we need to get all the holes really filled, and then we scrape out the extra. And do it from multiple angles is the best way of doing it. At least I found. There we go. Okay, so I'm going to use low airspeed. I actually still have my nozzle on here. I'm not going to worry about taking my nozzle off. And I'm at 400 degrees C. Some people will do it a little higher. And I don't even usually hold this one down. The chip's so small, it just will go pretty quickly. And now it should just go. Satisfying. I'm going to let it cool off for just a moment. I'm going to go slow. Okay. We're missing a couple of them. Did they just fall off when I just moved it just now? It was perfect 2 seconds ago before I moved it. It's stuck on the stencil. Okay, we're gonna pull them out. We're gonna put them in. Let me just reflow this real quick and then we'll add them in there. Okay, let me just reflow these. Oh, look, see, some of them are still not stuck. This is crazy that these did not even stick on here all the way. Yeah, look at all those. So 1, 2, 3. So we're just gonna set these here and then we'll be able to reflow it into place. It's not gonna be a big deal. It's just annoying. It's just another step. Okay. So all of them are located in the right area and they're all happy. Now we just need to reflow this without them blowing away. But the thing is that this is the customer's chip. It's probably bad or it has a bad programming. So maybe I should do something a little different on the other one because the balls don't seem to want to stick to these pads very well. So maybe I need to put a good amount of flux on the chip itself before we start, or a different type of flux. Because there you go. Now it looks pretty. All right, I'm gonna leave this out because we might need it again, right? All right. Is this gonna work? Let's solder it onto the board and see if the board turns on. If it doesn't, then we get to take the chip off and then we'll just transfer over the other one that's already on there. So this one's ready to go and the board is ready to go. So I'm just gonna set her down. All right, so the trick with this is we need to make sure this doesn't move. There is an outline here. So I'm gonna kind of apply pressure on the board more than the chip itself, but I just need to get it from blowing away. But once the solder starts melting, then it will stick in place. Okay, let go. Okay, it's stiff. We don't even know if this is gonna work anyway because this stupid chip was probably bad anyway, but there was a big ball under there. All right, so everything's nice and new now. Well, not new because we didn't replace the EC chip, but so when we do this EC chip replacement, if we do have to do it, I'm just gonna do a clean pull. We're not gonna reball or anything. I'm just gonna pull it off and then we'll do a complete transfer because those are easy enough to do. All right, so pay attention to the GPU, CPU. When we power this thing on, we should actually get the CPU right here heating up. We should also get some current on our current meter up there. 3, 2, 1. And the CPU is coming on, I cannot believe! Wow, okay, for science wins again. All right, so this machine came in, broke a DC jack. It's all like messed up, right? We pull it apart, The BIOS chip is on sideways. It has been hot glued on. The power management chip was blown out. We changed that out. The EC chip looked like something had messed with it. We pulled it off and there was a big ball of solder underneath it. And we just reballed it, put it back on, and we have signs of life. Now, we don't know if it's working yet, but I think that we have pretty good signs of it. So I'm not even gonna clean off this liquid metal stuff right now. I'm just gonna uncover this stuff and just stick it back on. Oh God, I hate this liquid metal. So the DC jack that's installed in here is junk. We're just gonna use my DC jack because it's not junk. All right, so I'm plugging in the power. We should actually get it to start posting or powering on immediately, and it is. We got keyboard backlight. I got fan spin. We got 3 amps. Now this will sit here usually for a little while around 60 watts, then jump to about 120 watts for about 2 or 3 minutes, and then it should actually get picture. But right now we are actually powering on, which is way more than we'd ever had done. It is going to full blast. Shut off, good. Now it should come back on, good. Hey, we have picture, I can't believe I saved another laptop. Boom. Now this one definitely was a crazy one. So a few different things we had to deal with, right? So the DC jack got damaged, it got ripped and mangled. And so trying a new DC jack did not solve the issue. Opening it up, we did find that we had some chips on and some chips not on under the thermal camera. Changing out the power management chip actually resolved our VDD line, which was stuck at 1.9 volts. That actually fixed that, and our AC detect was okay, but this board still wasn't coming on, just sitting at 0.02. And the BIOS chip was crooked. We put a new BIOS chip on there, reprogrammed that. And then we ended up having to pull the EC chip off, reball it, put it back on, and now we are functioning. Get into the BIOS. Right now we are in developer mode. Let me get out of that. F, there we go. Alt F, good. All right, we get to pick the motherboard. So this is an Alienware M18 with 4 SSD slots. Didn't we see that? Yeah, so it has 4 slots. They sell this as an M16 motherboard with 2 SSDs, 4 SSDs, or they sell it as an M18 with 2 SSDs or 4 SSDs. So this is the one that has 4. And the only reason why it's asking me this question is because I put a fresh BIOS on there. I kind of wiped everything out. It's booting Windows. So we got an inaccessible boot device. Is this a good or a bad thing? When you see a blue screen, read the freaking message on the blue screen, people. Please, read it. Nothing I hate more than you just say, I got a blue screen, the machine's blue screening, I don't know, but you have to read it. It says inaccessible boot device, which means that it doesn't understand the storage driver. So it's set to RAID, and this thing was installed with AHCI, which means it doesn't have the RAID driver, okay? So you just change that, and if it's the other way around, then just flip it, and then you're done. But sometimes you'll have a different one where it's talking about like, IRQ stuff or some memory stuff or NVIDIA stuff or whatever, it's talking about video drivers or corrupting, I don't know, whatever, just read it. RAID on an SSD? Yeah, so basically this is set up where you have multiple drives and then you can turn that RAID on and then you could do hardware RAID within this and set up where you have, mirroring and all that different stuff. So now we have this automatic repair error. So then you'll have these people say, oh, I was getting blue screens and now I'm getting automatic repair. And then sometimes it will boot to a BitLocker screen right here if you had BitLocker on here. It's not a big deal. Just hit skip drive if you have a BitLocker thing there. And then on this one, I'm just gonna hit advanced options and then I'm gonna say continue to Windows. Any benefits over RAID or NVMe? So what I set it to, AHCI is what I always set it to. Like if you're using like a Samsung drive, in order to get the full speed of your Samsung drive, you have to set it to AHCI. Like all these things are shipped with RAID on. That's period. That's how they do it. They put it on RAID. And then you have to switch it to the other one. And in order to, if you want to switch, let's just say you want to switch off of RAID to HCI, you just boot the safe mode the first time and then it will load the driver fine. And then when you reboot, it will work on that setting after that. So you can switch over anytime you want. We are booted in the Windows. Our display adapters. This has a 4080 in it, guys. 4080. 136 frames per second, 143, 77. And the reason why we're not running at very high frame rate, I'm only at 240 watts. If I put the 330 on here, then it will work. For science wins again. I saved another laptop.